So for exercise 4, what we're going to do is take the turtle walk program that we wrote up here with the turtles walking randomly two on the screen at the same time. And we're going to change it so that it doesn't end when a turtle leaves the screen or when the turtle collides with another turtle. What's going to happen is when a turtle leaves the screen, or if a turtle hits hits another turtle, what's going to happen is it's going to instead turn around. So it's going to kind of bounce off. So because we have our turtles moving in this grid pattern, this 90-degree turn pattern that we've been using, that's going to make it really easy to turn them around. Because all we're going to need to do when we want to have the turtle turn around is, let's say if Alex hits the wall, we would want Alex right 180, right? And that would turn him around 180 degrees and just point him back in the opposite direction. So we will code that in for both an instance when the turtles leave the screen and for an instance when the turtles are touching. They'll turn around and head off in opposite directions. So to do that, what we're going to do is we're going to need to start by making a function, a Boolean function, that checks to see whether or not the turtles are colliding. So I'm going to, up here, define is touching. And it's going to take turtle, we'll call it turtle 1 and turtle 2, because we're going to need to take in both turtles into account. So this is going to returns true if T1 is touching T2. Okay. So if you don't know how to do this, what you would need to do is go and look up the documentation for the turtle module in order to figure out, is there any way I can use to see if two turtles are touching, are on top of each other. And there are a couple different ways you can do it. For example, up at the top here, early on for our is in screen function, we use X core and Y core to get the location. And I believe there's even actually a value called a .loc or .location or something like that will give us the XY location for one of our turtles if we run it, if we call that. But we don't need to do that. Actually, there is a better way. There's an easier way. There's actually, the turtle object has a method called distance. And if you pass in another turtle object to a call to distance, it'll return how far away that turtle is from another turtle. So, in this case, we can say if distance from turtle 1 to turtle 2 is less than or equal to 1, so if they're within one unit of each other, essentially, then we want to return true because we're returning a Boolean. Else return false. That's all we need. It's just a Boolean that's when you give it two turtle objects, it'll tell you if those turtle objects are touching. Basically, if they're less than or equal to 1 unit away from each other. So that should work. We should be able to call that at any point to see whether or not the two turtles are touching each other. So what we need to do is we'll leave it as is right now in order to try to see if it works. But what we'll do is we will include, do I want to do it down here? There's no way for me to include it in move turtle really without refactoring. So I'm going to include it down in my main down here. So while they're in screen, and again we'll fix this later so that it takes care of it when they're out of screen as well. But while they're in screen, we want to move Julia and move Alex. and then we want to call if is touching, and then we'll pass in Julia and Alex. So that'll check Julia and Alex and see if they're within 1 unit of each other. Then we want to Alex right 180 and Julia right 180, and then we want them to go forward, so Alex forward 50 and Julia forward 50. Okay, so what's going to happen now is every time the screen kind of updates, right, every time it runs through this while loop, it's going to move Julia and Alex, and it's going to check to see if they're touching each other, and if they are, then they're going to turn them around 180 degrees and move them away from each other. So let's see if we can get them to run into each other. Nope. And we'll do it once more here, see if we can get them to touch. Nope. And go ahead and do it once more here. Okay, well, we're going to have to comment out this randomized start location. Instead, just move Alex to, let's pick 2020, and we'll move Julia to I guess we don't really need to move it anywhere. Well, no, because it's going to have to, because they move in things of 50, so let's move him to 50-50, and we'll leave Julia at 0-0 and run that and see what we get. So now they theoretically should possibly hit each other, which they didn't that time. Once more. Okay. It still did not happen. Alright. Well, I know for a fact that this is going to work. So we'll just need to have to implement that on faith at the moment, because there's not really a good way for us to test it without having to significantly refactor the code. Okay, so we have to deal with the fact now that they're going to still do this until they leave the screen. So what we want to do is we want to make it so where if one of them exits the screen, what we're going to want them to do is turn around 180 degrees and then march back onto screen. So because when they leave the screen here, they bounce out of the bounds here by 50, theoretically, then we want them to turn around and move back in by 100, you know? So we'll do that. Let's see here. So we want to get rid of this value of the while loop because honestly it's just going to stop every time that happens. And then what I'm going to do, and I don't recommend doing this usually, is I'm going to set this to while true. While true is going to create an infinite while loop. There's nothing that will stop this while loop unless I have a break statement in here somewhere. But I want them to keep running because that's kind of, in this case, the definition of the problem is to just, we have no endpoint according to the definition of this problem. So I'm going to have it run infinitely by just hitting it up with while true. And then I'm going to have it while true, move Julia, move Alex, and then if Julia's touching Alex, then have them bounce off. And then I'm going to have if is on screen. I think that's the name of our function. Let me scroll up and double check. Is in screen. Okay, is in screen. and then I want to check for Alex, and then I also want to do the same thing for Julia. So when they leave the screen, what we want them to do is turn around, again 180 degrees, and march back on screen. In this case, that's going to need to be 100 to get them back onto the screen. And the same thing for Julia, except obviously with her name in place of Alex's name. Alright, so it's going to run forever. So let's see how it goes. Oh, I have made a grave error here. This should be if not is in screen. Alright, I'm going to need to copy this and reload because that's an infinite loop now. Oops. Okay, let's try again. So I've switched it to where it does it when they're not in screen. Unfortunately, and you might have noticed, I had it set before to, if the way it was written before was if is in screen, then do this. So obviously they're going to be in screen most of the time, so instead of doing their regular function here, what they're doing is always doing their regular function and then always doing this stuff down here. So this should just work now. They're kind of bouncing away from the edge of the screen, and there are a couple of other different ways that we could have done this, but I think this way is the simplest with what we know how to do so far. For example, we could have had it set to where we could have written an if statement where we did something like if Alex x chord is greater than is greater than 200 or less than 200 or negative 200, that sort of thing, so that we could create these if statements that would turn them around if they go past the edge of our screen. But it's better to use the the is in screen function that we wrote previously for this case.